I am Anastasia Reinerson. I'm here representing the Kanazawa Technical College to present hands-on education at Kanazawa Technical College, or KTC. As you can see, I'm not Japanese. We provide our students a global education by emphasizing English. We have 3 study abroad opportunities in order to create what we like to call bridge engineers. Engineers who are able to bridge the cultural gap between English-speaking countries and Japan, as well as to understand the English language and to discuss technical problems in English as well. I'm here representing the Mechanical Engineering Department. We have 2 native-speaking English staff in each of our engineering departments. Oh, okay. So, Kanazawa Technical College is a technical college, which is a bit different than most Western university systems. In Japan, elementary school and junior high school are required. After you finish your junior high school, you can either join the workforce or continue your education through high school, like most Western educational systems, or you can join a college of technology, which offers roughly high school plus an associate's degree level in a technical major. After you finish at a college of technology, 30% of our students tend to go off to university and 70% join the workforce. So we need to be able to provide our students with not only the ability to join the workforce immediately, but also with a good grounding to continue on their education at a 3rd-year level in university. Japan has 63 technical colleges, which were started in 1952. These technical colleges were created to help to fill a gap, solve a problem with manufacturing and education. At Kanazawa Technical College, we are a private technical college, so we tend to be one of the front runners for the programs that are offered in technical colleges. One of our programs is our hands-on education system that we like to call creative design. Our creative design classes are a hands-on class in each year level, in mechanical engineering specifically, starting with the basics of processing and measurement, followed by a theory-based experimental class, the basics of mechanical engineering. In our 3rd year, we have the application of mechatronics. In our 4th year, it's a team-based project. In our 5th year, it's a team research project as our capstone. In our 1st year, our students get an introductory to engineering as well as to KTC. They learn the campus and the policies and are then split into 2 groups. One group goes into the machine shop to learn the machines and become certified for their future courses, and one group understands drafting. They learn how to draft and, in fact, will draft their project that they do in this course. For the 2nd semester, the students who have learned drafting will then go and create a part. They will create a calligraphy paperweight. Our students will also create balsa bridges. They understand statics and have hands-on projects that are very likely to give them success. For our paperweights, the stock is the same for all of our students. The general sizes and requirements are the same, but they are able to design the cross-section. So it's a hands-on project that gives them their sense of independence. They can create whatever they want, but they have a very high level of success. It's very difficult to create an incorrect project based on the standards we give them. For our 2nd year, we divide our students into 3 groups. One group learns the basics of electronics and breadboarding. They understand wiring and create a car from very different, or that does different levels of activity. One where it simply goes in a straight line, one where it goes depending on the variable light that it's given, and one where it follows a line. We also have students back in the machine shop. They learn the basics of gyroscopes, how they work, and then they create their own gyroscope, given an option of stock, and they choose what width to make in order to optimize the spinning time of their gyroscope. Our students also understand springs. They understand why trigonometry is important. By creating their own springs and then testing using weights that they have made in various configurations to try to see if the calculated and the experimental values are the same. So here is one of our gyroscopes and the electronics-based car. For our third year, we have an Applications of Mechatronics course. This course, the students create a line-following robot. First, they are given last year's robots, where they measure and draft using last year's parts. The reason they do this is so that they understand what needs to be part of the robot and the areas that you cannot change dimensions. They then optimize the design in whatever way they want. They can change the design, they can make it better if they find ways to make it better, or they can do whatever they want with it. They then draft in AutoCAD, and they must overlay all of the components to make sure that the different pieces match up and that the holes are all drilled in the correct positions. They return to the machine shop utilizing what they've learned in their first and second years to create all of the different components. We also have our students begin to learn more about the interpersonal and personal skills that will be required when they're out in the workforce. They create a Gantt chart. They know when they will be in the machine shop, but they are not quite certain what they will do when. So we ask them to schedule how much time they believe they will need for each component. So again, it's a very small, simple activity that has a high rate of success, but introduces them to what we want them to know. Once their line tracing robots are complete, they also present, saying what went well, what did not go well, and how they could better optimize their robot. All the line tracing robots look roughly similar to this. For our fourth year, our students must create a robot based on a theme. They choose the theme. This robot is meant to guide any visitors from the front entrance all the way to the office. The only thing that's the same with all the robots is that they must follow the line. They must all do different performances. And as you can see, or maybe not, this is a jellyfish. And it basically bobs its head and waves its hand. The sign in front says, "Please take my business card." So when the student took the business card out of the robot's hand, that was its signal to start moving. And then it brings the visitor to the front office. Not very far and not utilized much at KTC, but a good project that they can all get behind and they enjoy working on. This project involves C, D, I, and O. So they have to conceive what do they want to build in this robot, design the robot, implement it, and then run it a few times and prove that it will in fact operate the way that it's expected to. This also requires a bit more of the personal and interpersonal skills. The students work in teams of 6 to get the robot done. So we have them work on their teamwork. They must create their own schedule, so they learn more about Gantt charts. They also present at various times, and they work together to get the robot done on time. If they have any interesting calculations that they use, we also have them give presentations mid-year to show what exactly they did to figure out how to create the mechanism that they wanted to create. So they're also teaching each other while working on their communication skills. So our fifth-year students, it's a capstone project. Many students work on different competitions. So we have a GPS-based robot for the Scuba Challenge, and we have a micro mouse robot. These students must work in small teams, depending on the project, and then they give a poster presentation mid-year to show what they've done. They must give this poster both in English and Japanese. So they're working on their technical communication skills with the English poster, and then they have different faculty members come to see how they're doing and question them both in Japanese and English. At the end of the year, they give presentations, very formal, to not only the school faculty, but also to people from local businesses who are interested in helping our students. So why did we choose CDIO? Well, Japan has an aging population. It's believed that by the year 2050, over 50% of the population will be above the age of 65. Japan has one of the longest lifespans in the world, and it has a very low birth rate. So this is becoming a problem. Japan has also based most of its economy on manufacturing, which is becoming less and less feasible in Japan as costs are much better in other countries to manufacture in. So Japan must change. We must have better engineers. We must have better people who can trade in the ideas rather than actual products. CDIO will help us create these bridge engineers that we are trying to create in order to help advance Japan and Japan's economy in the future. So our students get surveyed every single year to see what they like, what they don't like about our classes. The hands-on courses in the mechanical engineering department always have very, very high enjoyment rates. This is because most of our hands-on classes have many aspects of CDIO involved. What we would like to do is to use CDIO as a tool to bring what makes our hands-on classes so great into our other departments. So we're using CDIO for our disciplinary field classes, and hopefully we'll be bringing it into our general courses and integrating more with our English and other classes to create a more full curriculum. Every 5 years, we survey faculty, industry, recent alumni, and other stakeholders to see how they feel our students are doing once they graduate. Now, many of our survey questions are very similar to the personal and interpersonal skills that CDIO looks for, but they are not quite the same. We want to know how our students do in terms of leadership, empathy, honesty, common sense, social responsibility, and many other personal and interpersonal skills that are not always a part of an engineering curriculum, as I'm sure you all know. We will be changing our survey in the future to see what exactly it can do against the CDIO syllabus, how our students are perceived when we add what's missing from the CDIO syllabus into our survey questions. For the most part, our faculty don't think our students do so well, but industry has a much higher opinion from our students, which is great. The things that we are most lacking in are actually our international communication, partly because our school has so many programs that it's expected that they're going to be at a very high level, and not all of our students are. So we're hoping to use CDIO to bring up the skills that are lacking in our graduates. Leadership is the other area where industry believes that our students are sorely lacking, and we believe that CDIO can help us bring up our students in that area as well. Now, some of the challenges for bringing CDIO into Japan include the language. Now, languages are always changing. Different cultures introduce different products and ideas to each other, and then introduce the words as well. So as a word enters a different language lexicon, then they can change the meaning. The nuance may not remain the same. In Japanese, it's called gairaigo, which are foreign loan words. Literally, it means outside coming word. So words that come in from the outside. There are many examples of this, especially in business and engineering, where ideas are exchanged quite a bit in the global marketplace of today. One word that's come up is research, or risachi. Pronunciation is not great, but I try. So research means something slightly different. It has a more broader meaning in Japanese than it does when you say it in English. It basically means to look up a word, whether that's to look in your textbook for the correct answer, or as we tend to believe when we say it in English, as an extended search through multiple sources to fully understand a topic. It can mean all of that in Japanese. From just a simple, what code do I use? Let me look through the textbook to find it, or the extended search that we tend to believe it is. Project, progetto, is also a word that has a different type of meaning. The meaning becomes more specific in Japanese. I actually had a conversation that left me very confused for a time when I first arrived. In my syllabus, I had planned for my students to do a project. So another teacher asked me, well, what are they going to make? I said, oh, it's actually going to be a paper design project based on what they've learned. And he gave me a confused look. What do you mean, paper? And a project, when you say it in Japanese, usually means a more solid thing that you make. Doesn't necessarily mean a long-term assignment like it could mean in English. A third word, role-playing, also has a different meaning, but this one becomes completely different in many ways. In Japanese, when you say that your students are role-playing, you tend to mean that you are assigning a leader, a secretary, different roles to a group or to a team that's working together. Whereas in English, it usually means acting out a scenario to see what you would do given a certain situation in the workplace. So the language barrier can definitely become a problem, especially when translating CDIO documents into Japanese. The 12 standards are an excellent, clear, concise list of what a school should do to be a CDIO school. The problem is that it's clear, concise, and excellent in English. When you translate many of the standards into Japanese, they don't remain as clear and concise. There really is no direct translation for context or learning outcomes. Therefore, these words are going to be, or at least we've been translating them as written in katakana, which is the way to pronounce a foreign word that comes into Japanese. And as you can see from the words that I've mentioned already, the meaning can change. So one hurdle that we're going to have to face will be to make sure that any words that we keep in katakana, any words that don't have a direct translation, keep the same nuance that they have when you say them in English, or that they keep the same meaning that CDIO wants. So we're still working on having everybody on the same page and getting the same understanding of the 12 standards and the syllabus. Our plans are to complete our translations and understanding of the standards and syllabus, as well as to most likely change the syllabus for our needs. We place an emphasis on foreign communication, so we'll probably expand that section. And we have a few interpersonal skills that we are more interested in focusing on, so we will likely add those as well. Once the mechanical engineering department implements CDIO, which we won't be doing as much as we would like this year due to our accreditation standards being up for review, once the mechanical engineering department finishes, our global information technology department will implement CDIO, followed by our electrical and electronic engineering department. Okay. Thank you very much. どうもありがとうございました。